Alright, so today we're doing complex number polar form. Okay, so again, we did do this last year, so it shouldn't be, hopefully, totally foreign to you. So let's consider the complex number z, where z is x plus yi. So the x is the real part and the y is the imaginary part. Alright, so our complex number, there it is there, and that point x and y. So for the polar form, so the polar form is where this point here is, this complex number is, in relation to the origin, so the origin of the pole. So there's a certain distance, and that's the modulus, which we looked at last time. But also we need some angle, and all our angles are always measured from that positive horizontal axis, the trigonometry in the x-axis, but for here the real axis. So that positive, and we always measure in the anti-clockwise direction. So if I was to draw a line out to there, then I would need to know how big that is, so the magnitude of z, and we use the symbol r, so if you like it's like a radius. And also the other thing we need to know is we need to know that angle. So if I then create myself a right angled triangle here, and this length is x and this length is y. Alright, so from that, the real part, that length there, using trigonometry, would be r cos theta, and the imaginary part, the y, again would be r sine theta. And the r, of course, is the magnitude, so x squared plus y squared square root of. So x and y can be expressed as x would be r cos theta, y would be r sine theta, where r it's the modulus of z, and theta is what we refer to as arg z. Now that arg z, if you like, is the argument of z, our complex number. And what is that? That's the angle. Alright. In the anti-clockwise direction, All right, and so more on that. All right, so from that, then, if we've got x and y, and so more on that argument in a minute. So if z is equal to x plus yi, then what we can do is we can replace the x and the y by these things. And so the x replaces by r cos theta, and the y by r sin theta. Then notice that the r is there as a common factor. So we can take that out. And when we do that, we've got cos theta plus sin theta I. Now, excuse me. Now, if we take the c, the I, and the S, and just use those letters instead of the shortened versions of cosine and sine, we can just use those letters and we can write it and say that Z equals R cis theta, where the C comes from the cos, the I from the I here, and the S from the sine. So cis, and I've written it all in capitals, which is probably not usually written in capitals, probably more likely written as CIS theta. So cis is, I always think of cis as cos plus I sine. And this is here, the last bit there, that is what we call the polar form. So it tells us how far from the pole, the origin, we've got to go, and then what angle we've got to turn to get there. All right. So let's have a look at an example of putting something in a polar form. Alright, so it says express negative root 3 plus I in the form r cis theta. So r cis theta, polar form. Every now and again you might hear it as referred to as modulus argument form, but probably more commonly polar form. All right, so what do we need? Well, R, we know is the magnitude of Z, and to get the magnitude of Z, what do we need to do? All right, take the components, the real component, which is root 3, and square it. The imaginary component, which is 1, and square it. So root 3 squared should be 3, 1 squared is 1, root 4. So the R, the magnitude of Z, the modulus of Z, is 2. And we only need to worry about the positive, we don't need to worry about the negative, because it's the distance we're going from that. Alright, so it's the distance from that origin, whichever way, wherever we're going, that distance that we're going out is 2. So we then need to know whereabouts we need to point go out there. And so, find that angle that we need to go. And we need to know the argument. So we need also to know what the argument of negative root 3 plus I is. And that's our angle that we need. Alright, so if I do a real rough sketch here, negative root 3 plus I would be over here in this quadrant. Yes, that we're part of negative root 3. So negative root 3, 1 there. And we can, what we want, of course, is this angle all the way around there. But related to what we've done before with our trig stuff, reference angle. Alright, so our reference angle let's work that out at the moment. So our reference angle we're looking at is tan minus 1 of 1 on root 3. And what angle has a tan of 1 on root 3? We know that triangle, I on 3, I on 6, root 3, 1. So opposite, adjacent, pi on 6 then, yes? Alright, so it relates to pi on 6. So that's, I should have used colour-coded with my green dot here. So that's what we've worked out for that green dot. So the angle that we're after is this one here, this theta. And so theta would be pi minus pi on 6, which is pi on 6. Okay, so we're using those solving trig equations, those quick equations, we're using that to help us here in this case. Alright, so finally we wanted it in this form here, r cis theta. So in r cis theta form, negative root 3 plus I, r is 2, cis 5 pi on 6. Alright, anything there anyone wants me to clarify before we move on? Alright, now if you're in exam 2, you'll have your calculator and you can, on your class pad, convert on your class pad. So the way we do that is on your main screen, you go to Action, you then go Complex, and so there we've got a whole, down the bottom 3 here, comp to pole, comp to trig, comp to rect. So complex number into polar form, complex number into trig form, which we don't use, or complex number into rectangular form, which we will use. So comp to pole, and so comp to pole, we now inside that bracket just put the complex number. So we'll need our keyboard to help us here, and our complex number is negative root 3. So negative root 3. Make sure you move out of that square root. It's only a tiny little difference. Hit the cursor. Make sure you move out of the out there. Was it plus I, wasn't it? Plus, and the I, there is an I, and the I is hiding in Math 2. Comp to pole, decimal, real, rad, radian's what I'm after. Non-real in calc, because I've got real not complex. Change that, and let's now go, and there we are. Now decimal, it's got all this decimal here, let's change that to standard, and there we are. So we've got this weird answer, haven't we? So let us think about, in this weird answer, the bits that we want. So from what we've just done over here, the 2 here, that's our magnitude, and they've got pi times 5 over 6, that's our argument part. Alright, so 2 cis, 5 on 6 pi. Alright, so as long as we know how to interpret, so what does that mean? That means 2 cis, 5 on 6 pi. Alright, so in exam 2, you have your calculator, so you'll be able to use that. Okay, so what else that I didn't mention yet? I've used the word a lot, and that's this argument here. Alright, so the argument is the angle, of course, so let's write something about that. Alright, so argument of Z. Oops, probably haven't spelled it right. Left it. Oh no, I have. There you go. Alright, so the argument of Z, arg Z, so it can be written arg Z or capital. Now, with this, little a is a general solution. So you remember when solving the trig equations, general solution, we just keep spinning around in circles. So that would be the little a. The big A would be like what I've done over here in this example. Alright, so general solution, you just plus 2n pi, isn't it? You can spin around and round in circles. Right, and turn that much, or I can keep going around and round. So that's the little a, the general solution. Not much fun. The big A is like a specific solution, if you like. And also, really bigger A, big arg Z, it's between negative pi and pi. So we don't double up. So bigger arg Z between negative pi and pi. So you need to make sure that if you're doing the third or the fourth quadrants, we're coming back in the negative. Negative pi is not included because pi is, if they're both be included, you'd be including the same point twice, which we don't want to do. So it's like that. All right. So, yep, just need to do that. I had a lot more words than that. Is that enough words for you? I had a lot more words in my notes, but anyway. All right. Complex conjugate. In polar form. All right. So in rectangular form, we had z is x plus yi, and our conjugate is x minus yi. Now, when we relate that to polar form, if z is r cis theta, then the conjugate is r cis negative theta. And if you really want to know the proof to that, it's on page 170 of your text. You can have a look at that. All right. So it's pretty simple to find our complex conjugate if we were already in polar form. So an example. Alright, so if we're finding the conjugate of that, z equals root 3 cis pi on 6, all we need to do is say it's root 3 cis negative pi on 6. Alright, so pretty straightforward in polar form. Alright. We might need to go polar to rectangular form. So the polar form, of course, is the cis theta, and the rectangular form is the x plus yi. All right, and so we just use those, excuse me, those relationships from before to figure it out. So let's have a look at the example. Express. Seven, 3. All right. So to do this, we've just got to, our A relates to our first part there of the cis, our B BI, that relates to the IS bit. so, and since we've got the modulus, magnitude, size, an R of 2, we can now say that, alright, so A is related to this, the C is cos, so A would be 2 cos negative 3 pi on 4. The B is the second part, the sine part, so the B then is 2 sine negative 3 pi on 4. And so we need to know what the signs of those things are. So negative 3 pi on 4, what quadrant's that in? Rough sketch. Negative 3 pi on 4 goes this way and in the negative direction to here. It's in the third quadrant. So in the third quadrant, and the reference angle, is that reference angle there is pi on 4, yes? Alright, so third quadrant, cos is negative, and pi on 4, root 2 on 2. 2's cancel, give them negative root 2. For the B, sine is also negative. And because it's pi on 4 of the reference angle, it's also root 2 on 2. 2's cancel, leaving with negative root 2. So, what that means then is that our complex number, 2 cis negative 3 pi on 4, is equal to negative root 2 plus minus root 2 pi. Alright, anything there I went too fast over? No. Alright, so also in exam 2 you've got your calculator, you can do this on your calculator. And this is how you do that. Don't know who I am. Alright, so same place that we went before, action, complex, the bottom one there, direct. Now we need to put another little symbol in here. And this other little symbol we put in here is an angle symbol. And we need to go to Math 3 and see down at the bottom here in Math 3, and down there, there's a kind of little angle, so we need to put that there. So that the calculator knows there's an angle involved. And what did we have? So first of all we put our modulus first, our R, so that's 2. Then after that we put a comma. And then we put our angle bit, which was negative 3 pi over 4. And then we go EXE. And there it is, it's taken the root 2 out as a common factor. Alright, anything on any of that? Right, as I said, you've done a bit of this last year, so hopefully it's not completely foreign. Alright, we're up to Question set 3-4C in questions on your work plan.